Welcome back, geometry students. Okay, so here's what I did some research. This is what an emu looks like. These are ugly birds. Looks like it's a giant eyebrow as it goes all the way across there. Yeah, and then officials warn of emu on the loose in North Carolina for 3 weeks. And here's another one. It's like Orange County emu still on the loose. Sightings reported Thursday. I don't know if I'd want a emu now. But obviously these things run around like wild, so if you had one, you got to build a fence for it, without a doubt. So just the, advice from your old math teacher, Mr. Flans. If you get an emu, get a fence. Don't let these things run wild, please. Obviously they must cause some sort of havoc that people are freaking out when these things escape. And it is not pretty, man. I don't know. Look at this guy. Woo! That guy looks like he's seen better days. All right, so let's keep going here. Yeah, these are ugly guys, man. Okay, so let's imagine I have my emu. Okay, and we're gonna get back to doing the emu problem in a second. All right, let's focus this thing a little. I'm gonna turn on the light here. It's going to get bright for a second, and it's going to come back down. Okay, so the length of a semicircle with a radius of 1.3 meters, and leave your answer in terms of pi. I love when they say leave your answer in terms of pi. Technically it's more accurate, because I don't have to round usually a decimal with this. So it's giving us a radius, not a diameter. So I can use C equals 2 pi r. Now the problem is, it's a semicircle. And if you remember, a semicircle is half of a circle. So if I want to find just how much this is, this top half of the circle, this outside the circumference, the perimeter of a circle, as you would say, I have to do something. Okay, so here's what I do. If I'm only looking for the circumference of part of a circle, let's say I was doing this. Remember we were talking about the angles the other day? Like, let's say that's 90. That kind of looks like my emu problem. We're going to get that emu in a second. So I'm going to put here C equals, now if you look in the guided notes, right, up here, they do this. Measure of angle AB over 360 times 2 pi r. So I'm looking for actually a percentage. How much? Now, 180 works out nice. So what I do is I take the number 180, because I know the measure of this angle is 180, over 360 times 2 pi r. Now, 180 divided by 360, if you know your math real quick, you're going to see it's really just 1/2. 1/2 times 2 pi r. So if I didn't know that, you'd do this and you'd say, you could do it this way. So let's say I was working in the calculator and I said, okay, 180 divided by 360, 360 being the full circle, 180 being the angle we're measuring, times 2 times pi times the radius, which is the only thing I put in here is 1.3. And I'll get a number, but they want us in terms of pi. So it's 4.08475. So it's going to be around 4, but they want it in terms of pi, so let's do it this way. All I'm going to do then is not multiply pi with this. I'm going to change the thing around. If you remember, with multiplication, the order does not matter. Times r times pi. So I'm putting the pi at the end. I'm switching the r and the pi places. Then I'm going to do this. 1/2 times 2 times my r is, remember, 1.3. I'm going to put like parentheses around to show we're doing that and keep the pi on the outside. Now, 1/2 times 2 is just 1. 1 times 1.3 is 1.3. So you do this math, if you're not sure, or you could do 180 divided by 360. Okay, first part of the problem, times 2. But I want to keep it in terms of pi, so I'm not going to multiply the pi in there, and I'm going to multiply 1.3. I can put the pi in later if I want that exact number of 4.08, which would make more sense if I was building a fence, let's say. So this number is just 1.3, as we said, and it's going to be multiplied by pi. So if they say they want something in terms of pi, okay, in terms of pi, that means you just leave the pi on the outside. Now, if they want something in terms of an actual number, like my emu problem, okay, so my emu fence that's at the corner of my apartment building here in Queens, it's got to be 7 feet. We said it's going to have to be at 7 feet, which I think is probably a little small. Maybe it's a baby emu. And how much fencing do I need to keep the emu in here? So this ugly emu bird, I don't know. You might want to get out. Okay, so I don't need the circumference of a full circle. I only need the circumference of 3/4 of a circle, because this is a 90 degrees there. So I take 360 minus 90, and that's 270 degrees. So this angle here is 270. So what I'm going to do now is do 270 over 360. I'll move this up so we can see it. Times 2 pi. Now here, in my emu problem, I'm not going to go into Home Depot and tell the guys there that I want this in terms of pi. They'll look at me strange, right? They want to know exact feet, so that's what I have to do for them. So 270 divided by 360. I'm just doing this in the calculator. It's really 3/4 or 0.75, but if you have the calculator, no need to worry about this. So you put the actual angle that you're measuring, that part that you're measuring, that angle, you divide it by 360, and it's going to give you a percentage of the total circle you need, because I don't need to know this little half here. Times 2. This time I'm going to use pi, because I got to give the guys at Home Depot an actual number in feet, and I'm going to do it by the radius, multiply it all by the radius, which is 7. Error in my syntax. What did I do wrong? Double division. Someone should have told me, you guys. So I'm going to have to go into Home Depot. I guess I'm going to round up to the nearest whole number. And I'm going to ask them, I'm going to need 32.98 is almost 33 feet of fence to make my emu run, my emu fence, my emu, I don't know what. It's going to be big, because if that emu escapes, it obviously cause some sort of panic. Probably scares the heck out of the neighbors. All right, guys. I will talk to you later. Have a great day.